Hello everyone. Welcome to the AI for All channel. Today we're going to talk about a fascinating topic: how artificial intelligence algorithms make decisions. Have you ever wondered how AI decides which series to recommend to you, how it analyzes thousands of routes to suggest the fastest one on your GPS, or even how advanced systems make medical diagnoses? AI is behind many of our everyday interactions, and all of this happens thanks to its powerful algorithms. But how exactly are these decisions made? What happens behind the scenes when AI makes a choice? Let's dive into this world and explore how these digital minds work. Stay with us and find out. 2. What are AI algorithms? To understand how AI makes decisions, we first need to know what artificial intelligence algorithms are. In simple terms, an algorithm is a series of instructions that a machine follows to solve a problem or complete a task. But AI algorithms are far more complex than just simple instructions. They are designed to learn from data and adapt to new situations. AI algorithms are fed with large amounts of data, which can be images, texts, sounds, or even sensor-generated information from devices. There are different types of algorithms, such as those that learn in a supervised way, where they receive labeled examples, like photos of cats and dogs, to learn to identify new examples. In unsupervised learning, the algorithm tries to find patterns in the data on its own, without prior labels. And in reinforcement learning, the algorithm acts and learns from its attempts, adjusting its decisions to maximize rewards. An interesting point here is that AI doesn't just follow fixed rules but also creates its own strategies from the data. For example, in a chess game, the algorithm can develop tactics it was never explicitly taught, adjusting its decisions as it plays more and more matches. This is what makes AI so powerful and, at the same time, intriguing. 3. How do algorithms process data? Now that we understand what AI algorithms are, let's see how they process data. Imagine you have thousands of pictures for AI to learn to differentiate between cats and dogs. AI doesn't see these photos the same way we do. It first converts the images into numerical data that describe aspects like color, texture, edges, shapes, and other visual patterns. This processing is done in stages, especially in neural networks, which are an advanced type of algorithm inspired by the workings of the human brain. Each layer of the neural network analyzes different features of the image. The shallower layers might identify simple shapes like lines and contours, while the deeper layers can start recognizing more complex structures like eyes or ears. In the end, the algorithm combines all this information to make a prediction: is this a cat or a dog? Besides images, AI algorithms process many other types of data. In virtual assistants like Alexa or Google Assistant, the algorithm converts your speech into text and then analyzes that text to identify the command you gave. In the case of a GPS, it receives real-time traffic data, like congestion or accidents, and calculates the best route based on those factors. Each type of data undergoes specific processing to be understood by the algorithm. For a decision-making, the probability-based choice. After processing the data, the algorithm needs to make a decision. And how does it do that? By using probabilistic models. This means that instead of making absolute choices, AI algorithms work with probabilities. They calculate the chances that a certain response or action is the correct one based on the available data. Let's take the example of a music recommendation system like Spotify. The algorithm analyzes your listening history, the songs you've liked, and compares it with the behavior of other users who have similar tastes. It then calculates the probability that you will like a new song and makes the recommendation based on that probability. Similarly, a virtual assistant like Siri can calculate the probability that you want to know the weather when hearing the word weather and will respond with the forecast. These algorithms are constantly adjusted to ensure that predictions and decisions are as accurate as possible. For example, a food delivery app can use data on preparation time, traffic, and location to predict the exact delivery time. These systems need to process large volumes of data quickly and make a choice based on the most likely scenario. 5. The role of feedback, improving decisions. AI algorithms are not static, they learn from the feedback they receive. Every time an algorithm makes a decision, it gathers information about the outcome of that decision to improve future choices. This process is called continuous learning. Let's think about a movie recommendation system like Netflix. When you watch a movie suggested by the algorithm and give it a positive rating, that information is recorded. The algorithm understands that the recommendation was successful and will use that information to adjust its future suggestions, prioritizing films similar to what you liked. On the other hand, if you reject several recommendations in a row, the system learns that it needs to adjust its approach. In reinforcement learning, feedback is even more critical. Think of an autonomous car that needs to learn how to drive. It receives real-time information about its actions, like braking or turning, and their consequences, whether it avoided an obstacle or caused an error. With each interaction, the algorithm adjusts its behavior to improve driving. This means that, over time, algorithms become more precise and effective in their decisions. 6. Limitations and challenges in AI decision-making. Despite AI's impressive potential, there are limitations. One of the biggest issues faced by AI algorithms is the quality of the data. If the data feeding the system is incomplete, outdated, or biased, it can lead to incorrect decisions. For example, an AI system used in recruitment processes might perpetuate biases if it's trained on data reflecting historical inequalities. Another challenge is transparency. Many AI systems, especially those using deep neural networks, are often described as black boxes. This means that while we know the algorithm is making decisions, we don't know exactly how it reached that conclusion. This is particularly concerning in areas like healthcare, where AI might be used to diagnose diseases, or in courts, where judicial decisions could be influenced by automated systems. Moreover, AI faces ethical challenges. A classic example is the dilemma of autonomous cars. If the car encounters a situation where it must choose between two lives, how does it make that decision? These dilemmas show that automated decision-making raises complex questions that go beyond calculations and probabilities. 7. Explainability and transparency in AI algorithms. As artificial intelligence becomes more powerful and pervasive, one of the big challenges that emerge is the issue of explainability and transparency in algorithms. Many AI systems, especially those using deep neural networks and other advanced learning models, are often described as black boxes. This means that although we know these systems make decisions based on data, it's often difficult or even impossible to understand how they arrived at a specific conclusion. This lack of transparency can be a problem in various critical areas. For example, imagine an AI system being used in a medical diagnosis. If an algorithm recommends a specific treatment for a patient, both doctors and patients want to know the reason for that recommendation. How did the algorithm come to that conclusion? Did it analyze the patient's medical history? Did it consider all the relevant factors? The lack of clarity can undermine trust in AI systems, especially in scenarios where explanation is essential. Additionally, in legal or financial decisions, explainability is crucial. If an algorithm is involved in credit approval, for example, it's important that people affected by these decisions understand the criteria that led to the approval or denial of credit. Similarly, in court, if an automated system is used to suggest sentences or assess a defendant's likelihood of reoffending, it's essential that the decision be understandable and transparent. To address these problems, the AI field is beginning to explore concepts such as explainable AI, XAI. The goal of XAI is to develop models and algorithms that can not only perform tasks with a high level of accuracy but also provide understandable explanations of how decisions were made. This is especially important in highly regulated sectors like healthcare, finance, and public safety. Another important concept is algorithmic auditing, where experts review and analyze the behavior of algorithms to ensure they are not introducing bias or unintended discrimination. This is becoming increasingly important as algorithms play a central role in decision-making processes that directly affect people's lives. Finally, there is a growing movement to create regulations that require AI systems to be transparent and explainable. Several governments and organizations have already started developing guidelines to ensure that algorithms used in important decisions are fair, transparent, and understandable. This also aligns with ethical and accountability concerns in AI, ensuring that systems are used responsibly. 8. Conclusion. Now that we've explored how AI algorithms make decisions, did you get a better understanding of how these digital minds work? From data collection and processing to probability-based decision-making and learning from feedback, algorithms are increasingly present in our lives, influencing everything from our purchases to how we move around. However, as we've seen, AI also brings challenges and limitations. But with the continuous advancement of technology and the improvement of these algorithms, we are heading towards a future where AI decisions will be even more precise and reliable. Did you enjoy the content? Don't forget to subscribe and like the AI for All channel to stay updated on more news about technology and artificial intelligence. See you next time.